So example, telling the review. So consider f of x equals x cubed minus 7x minus 10. First question. Use the intermediate value theorem to show that f has a 0 on interval -1, 4. First question. Second question. Find a number in -1, 4 that satisfies the MVT, so the mean value theorem. And C, use Rolle's theorem to show that there is a value C in -1, 3 such that f prime of C is 0. Okay, first question, use the intermediate value theorem that it has a 0 between -1 and 4. So A. So what we're going to do is we're going to check that f is continuous. Yeah, so f is a polynomial function. Therefore, it is continuous. Okay, so every polynomial function is continuous. There's no denominator, there's no square root, there's no issue. Okay, no restriction on the x, so it's continuous, it's even differentiable. Let's check that f, what's the value of f of -1? So if I plug in -1 here, what do I get? I get -1 plus 7 is 6. 6 minus 10 is -4. And f of 4 is what? So 16, no, sorry, 64 minus 28 minus 10. So I get 26. Okay, so basically what we have here is a function like this. At -1, it's -4, and at 4, it's 26. And the function is continuous. So by the intermediate value theorem, there for sure is going to be a place where it's going to cross the x-axis. Okay, so we're going to write it formally. So since f of -1 is less than 0 and f of 4 is greater than 0, then by the intermediate value theorem, there exists a value C for which f of C is 0. Okay, every intermediate value between -4 and 26, every intermediate value here, there is going to be a number between -1 and 4. That is its source. Okay, that's it. That's how you solve the first question. What's important in these questions is the wording and the fact that I'm sure that I understand that you have validated the hypothesis of the theorem. Okay, when we're talking about theorems, we always have to be more careful with the wording. Okay, and have to be precise.
Okay, so we don't have to like actually find the value where is it?
No.
It's 0. Okay.
You can't. I don't think you can. It's a third degree polynomial. We haven't learned this. B. So final number that satisfies the mean value theorem. Okay, so again, f is a polynomial function. Therefore, it is differentiable. Okay, for the mean value theorem, the function needs to be differentiable. Okay, and by the IVT, the MVT, mean value theorem, there exists a C in interval -1, 4, such that so f prime of C is equal to f of 4 minus f of -1 over 4 minus -1. Okay, that's the mean value theorem. Okay, so I'm going to need the derivative of f, which is 3x2, so 3c2 minus 7, that's the derivative, equal f of 4, which is 26, which is found, minus f of -1, which is -4, over 4 minus -1, so 5. And so that's equal to 6. Okay, and therefore, if you solve this, 3c2 minus 7 equals 6, 3c2 equals 13, 3c2 equals 13 over 3, and so c is equal to plus or minus square root of 13 over 3. Okay, so these are two values. Are they both between -1 and 4? Let me see. So 13 divided by 3 and the square root of that. So -1.6, no, not good. So I just have to accept the positive one. Square root of 13 over 3. Oops, sorry, you can see the bottom. Okay, the last part, which has to do with Rolle's theorem. Okay, so we know it's continuous, we know it's differentiable. So f of -1 is equal to -4. And f of 3, right now the interval is between -1 and 3. F of 3, if you plug in 3, you're going to get -4 again. Okay, then by Rolle's theorem. There exists C in -1, 3 such that f prime of C is equal to 0. Okay, so let's find the C. So f prime of C, the derivative is 3c2 minus 7 is 0. And so C2 is, so yeah, C, go straight to C, is plus or minus the root of 7/3. And again, the minus won't work. So C is the square root of 7/3. This is the value of C. Next question. Find the absolute extrema of, okay, so the maximum and minimum of f of x is equal to ln x over the square root of x on interval 1 e power 4. Okay, the max and min of this function on this interval. Okay, so the first thing we do is we find the derivative. So f prime of x, so there's a quotient rule here. So the derivative of the top, which is 1 over x times the bottom, minus the top times the derivative of the bottom, over, oops, over the bottom square, which is just x. And so that is equal to what? So root x over x is 1 over root x. So I'm just going to basically multiply the top and the bottom by root x, by 2 root x. Okay, I'll multiply the top and the bottom by 2 root x. That way, I'm going to get 2 root x times root x over x is 2, minus, this is just ln x, and on the bottom I have 2x root x. Okay, so there is a discontinuity at 0, but anyways, we're on interval 1 e to the 4, so there's no problem with, there's no issue. Okay, even here, there's an issue at 0. We're not, it doesn't concern us because it's not in our interval. So when if this becomes 0, so f prime of x is 0, if and only if, so 2 minus ln x is 0, which means ln x equals 2, x equals e power 2. That's it. So now I just need to verify the value of the function at the 3 values. So f of 1, f of e to the 2, and f of e to the 4. Okay, so f of 1, you get 0. F of e to the 2 is 1 over e. And then f of e to the 4, no, sorry, not 1 over e, it's 2 over e. And then e to the 4, you replace e to the 4 here, you get 4 over e to the 2. That's it, which is the lowest. Obviously, this is the lowest. And which are low. I think this one's lower. So this is the highest. Let me see. 2 divided by E, 0.73, and 4 divided by E squared, 0.54. There you go. So this is the min, and this is the max.